Hi all. So today's topic is connecting LANs. So what is the meaning that it is a connecting LANs? Either a host or a LAN device, they do not operate in isolation. They need something to have as a connecting device in between. So that is what we are going to call it as connecting LANs. So these connecting LANs are helpful for us, or these connecting devices operate at different layers as per our internet model. And in this particular session, what is that we are going to discuss is what are the devices that are there at different layers of the internet model, and we are also going to look at the working of each one of those connecting devices. Coming to the first thing, so we have divided these connecting devices into 5 different categories based on the layers in which they are going to operate in an internet model. So the topics that we are going to discuss here is passive hub, active hub, bridges, 2-layer switches, routers, gateways, 3-layer switches, etc. So coming to the very first one, so we have 5 categories of connecting devices. So coming to the internet model, which is given at the left hand or at the right hand, so we have the very first lower layer, which is physical layer, then data link layer, network layer, transport layer, and then the application layer. So coming to the passive hub. Passive hub, it is a connecting device which is present always below the physical layer. And then coming to the repeater, uh, these these are the devices which operate at the physical layer, and repeater, we also call this repeater as hub. And then coming to the next layer, those devices which operate at physical and data link layer, we call that as a bridge, or it is also called as a 2-layer switch. Then moving on to the next highest device, that is those which operate at both physical, data link and network layers, we call them as a router, or it is also called as a 3-layer switch. And above all, if there is a connecting device, if this device is capable of operating at all the different 5 layers, then we call that as a gateway. So that's the layer representation of each of the connecting devices. So if it's coming for the if it's present at below the physical layer, we call that as a passive hub. Coming for the very first device, which is a passive hub, it is just a connector. What do you mean by it is just a connector? What are the lines that are running from, or whatever the wires are coming from different branches of an LAN connections, they come and get the connection done to the given module or given device through this passive hub. So we call this as a connecting end, or it is also called as a connector. Then moving on to the next one, which is a repeater. So coming to the repeater, we have seen that, or we have made use of this term repeater frequently. So a repeater is a device that operates only in the physical layer. Signals that carry information within a network can travel a fixed distance before attenuation endangers the integrity of the data. What does it mean? So repeater is required, or this device repeater is placed in the LAN connection where it can operate, or where it can strengthen the signal, or where it can strengthen the data, and it is going to transmit that set of the original data to the next device, or to the next segment. So the repeater, it receives the signal, and before it becomes too weak, what it has to do is it has to regenerate those original bits, and that's the name repeater. And those regenerated original bit pattern is forwarded to the next length of the LAN cable. So that is what is done here. You can see that there is a repeater which is present here. So this is one host or one device which is getting connected to the repeater, and this repeater, it is actually connecting to one single LAN. Coming to the point that repeater will never have, or repeater, it is not going to operate for two different LANs. It will operate only with one single LAN connection. So instead of drawing a very lengthy LAN cable, we have a repeater in between. So this repeater is going to actually regenerate or regenerate the original bits of the signal and pass it on to the next segment of the same length of the LAN. So that is one more point to be concentrated here. Repeaters do not actually connect, or they do not connect two LANs operating with two different protocols. Instead, they have the connection being done for a lengthy cable of the LAN cable or the Ethernet cable. It breaks that lengthy cable, repeats the sequence, and then transmit the sequence further. So that is how it has been done here. You can see there is one segment of the LAN and there is second segment of the LAN. Both the segments of the LAN here are of the same LAN, which is one single LAN that is present, but we are making use of a repeater in order to strengthen the original information. So that's a point to be noted. A repeater connects segments of a LAN. It cannot operate between two LANs operating with two different protocols. Then repeater, what is the job of this repeater is, it forwards every frame, but it has not got any kind of filtering capabilities. Then repeater is a regenerator, it's not an amplifier. So what comes to the mind as soon as we say it as a repeater is because we think that it's a kind of amplifier. No, it is not. It just tries to compare, or it just tries to help us to get back the original signal or regenerate the original signal. Neither it is going to amplify, or it is going to help us to get the amplified signal. We know what is the job of an amplifier. It is going to actually strengthen both the signal and the noise. It is not going to discriminate between the signal and the noise, the original signal that is required and the noise. It amplifies equally everything that is fed into an amplifier. But whereas a repeater, it does not amplify the signal, it regenerates the signal. When it receives a weakened or corrupted signal, it creates a copy of it. So the bit for bit at the original signal strength. So every copy of the signal is copied, and then the strength of each bit is being done with the help of a repeater. So that's why we say that repeater is a regenerator, it's not an amplifier. So coming for the function of a repeater here, you can see either the left to right transmission or right to left transmission of the signal with the usage of the repeater. So the location of the repeater in a link is very important. Where do you place a repeater is very important, which means placing the repeater so that the signal, before it reaches any noisy changes, we have to avoid that kind of noisy changes to happen over the length of the cable. So if we place it like after it gets added with the noise, it's of no use for us. The repeater, what does it do? It just copies the bits and then again keeps on repeating the original signal. So that should not happen. So we have to place this repeater in such a way that where it can avoid these kinds of bit voltages, that is, a little noise can alter the precision of a bit's voltage. We know that without destroying its identity. And if this corrupted bit travels much farther, accumulated noise can change its meaning completely. right? So what is that we want to do? At that point the original voltage is not recoverable and error needs to be corrected. So we have to place this particular repeater in such a way that there is no error being added or there is no noise being added to it, and then we are trying to transmit that repeater or regenerate the signal that has been already lost its strength or corrupted its strength. A repeater which is placed on the line before the legibility of the signal becomes lost, or before we could read that particular signal, before we lose that particular voltage of the signal, what we can do is we can try to determine the intended voltages and replicate them to the original form. That is the usage of the repeater. The next is we have the hierarchy of hubs, or we know these active hubs. What are these active hubs? It is the presence of the bridges, or active hubs are also called as repeaters, which we have seen just now. So just a multi-part, an active hub is actually a multi-part repeater. So more number of repeaters which are present, so which will constitute an hub, that is an active hub. Then moving on to the bridges, the next topic, which is bridges that operate between both the physical and the data link layer. As a physical layer device, what does it do is it regenerates the signal it receives with the help of a repeater, and as a data link layer device, the bridge can check the physical addresses. When I say physical addresses, it is the MAC address, that is the source and the destination address present in the particular frame. So that will be done at the bridge, which is there present at the data link layer. Now coming to one extra property of this bridge is this bridge has got, or if there is a difference that has to be noted, so the difference in functionality between a bridge and a repeater is a bridge has filtering capability. What is this filtering capability? It is nothing but the bridge knows which frame has arrived. Depending upon the arrival of the frame, it has to always check for the source address and the destination address. If at all it is matching with its host address, then the intended frame is for that particular host, or else it has to forward that particular packet or that particular frame to the next host. So that is what is one filtering capability that is available with the help of with the presence of a bridge. A bridge it also follows a tabling property, or it also maintains a table. A bridge has a table that maps addresses to ports. And coming for you can see here we have given the hierarchy of bridges or hierarchy of the hubs. What is this hierarchy of hubs is, we have seen that there is an active hub which is present, or a repeater which is present. Multi-part repeater, we called it as active hub. So this hierarchical use of hubs actually removes the length limitation which was earlier used at the 10 base T model, which we have seen earlier. So the limitation was 100 meters. Now if I keep increasing this hierarchy, I can actually reduce the length of the LAN cable. So we have noted that a bridge has two capabilities. One is it maintains the table, and one more is it is going to take up the decisions based on the filtering mechanisms. And coming for the example here, a bridge connecting two LANs. So you can see there is a bridge which is connecting two LANs here, which is LAN 1 and one more is LAN 2. So there are hosts which are being addressed, or the MAC address of the first host is 71 2B 13 45 61 41, like that 42, and on the other end we have 12 and 13. So now looking at the bridge table, what we notice is 71 2B 13 45 61 41 has to leave through the port 1 because it is connected at the LAN 1. And then we have another one like 64 2B 1345 6112, which is connected to LAN 2. So any data which has to pass through, it has to travel in the other direction. So when it comes for such kind of analysis, what is done at the bridge level is, as an example, so this address, say suppose if a frame destined for station 42, that is stationed this 71 2B 1345 6142, arrives at port 1, the bridge will go back, look at the table and find the departing port. And now the departing port here, it is given as 1. If you can see, the departing port number is 1. So with the usage of this, it tells that therefore there is no need for forwarding and the frame is dropped. So a frame is arriving at that particular device, it's already there present on the same LAN, so it will drop that packet. Coming to one more example, let us take the another example, which is 71 2B 13 45 61 41. So the frame is having, or it is containing an address as 41 here. So that arrives at this port 2. So when it arrives at this another port 2, the departing port for that particular address is what? It is 1. So when it is 1, it has to be what? It has to be transmitted to that particular port 1. Then the frame will be forwarded to the particular device and the device gets the frame. So that is how a bridge is used. It looks for which port, which address, keeps on, if at all the frame address or the destination address is correct, it will accept the data, or else if it is already present there, it will drop that particular frame, and if it is a new packet, it will receive that frame depending upon the presence of the correct or the proper MAC address given or present with respect to that destination address. A bridge, it does not change the physical address or the MAC address present in the frame, which we have already noted. So we have the next topic, which is transparent bridges. So this transparent bridge, it is a bridge, though it is existing, the complete set of the network is unaware of it. Means if a bridge is added or deleted from the system, reconfiguration of the stations is not required. It is unnecessary. So such kind of bridges, we call it as transparent bridges. So now we will come to that point of this particular PPT or the slide which is showing learning bridge. So what should be the properties of, or what should be the specifications according to 802.1d that a bridge, that is a transparent bridge, must be having? One is that system with transparent bridges, it must have frames which is capable of forwarding from one station to another station, and then it should always maintain a forwarding table that is automatically made from learning the movements of the frame in that particular network, and then loops in the system must be prevented. So coming for the first concept, which is forwarding and learning. Frames movement, how do we make the frames to get forwarded from one station to another station is based upon the address, right? So that is what is forwarding. So forwarding table has to be automatically made. What does it mean? So if I am forwarding a packet from a known device to known device, it is fine that I look at the forwarding table, and if an entry is there, then I am going to make use of that port number to forward the packet. If at all there is no entry, what we have to do? We have to learn. So the learning bridge has to be taken care of, and then automatically the learning table has to be updated. So coming for the first terminology, forwarding is a transparent bridge must correctly forward the frames. And then coming for learning, looking at the movement, looking at which station is trying to transmit the data. whether I am going to make use of a static data or a dynamic table. So we have to, static table or a dynamic table. It is dependent on the particular scenario. So now since we are looking at the transparent bridges, we have to, it is always better if we consider the dynamic table wherein we can keep on adding the new stations which come into picture. So now let us look at how the learning process or how the bridge is going to learn to enter its data in the dynamic table. So coming for station A, let's assume that station A has some frame to be sent to station D. Now the bridge does not have any entry at the very beginning level, as you can see here. Now what does this station A does? It has to it has to forward the packets in all the three available ports, that is in port 1, port 2 and port 3 of the bridge. So once this is done, it will identify that the bridge or the station D is present at port 2. So what does it will write in the next table here? The updated table is the address is A, what is the port from where the packets or the frames has to move? It has to leave from the port 1. Then the flooding then the next is we have let us say there is a station E. This station E, it wants to transmit the data to A, to the station A. The bridge has an entry for A already, like if any incoming data from A or any outgoing data from A, it has to go through the port 1. So that is already there, which is mentioned in this particular table. So now it's easy for E to transmit the data, but now E need not flood the data in all the three ports of the bridge. Instead, since the entry is already made, so it can just transmit the data or transmit the frame through the port 3. Likewise, we have for a station B. Now station B wants to transmit the data frame to station C. So when station B sends a frame to C, the bridge has no entry for C. So once again it floods the network. So there is no entry present in this particular table. So what it has to do? It has to first find the station. So the frames has to be flooded in the network through the help of the bridge. And then so once again it floods the network and adds one more entry to the table, that from B, if I want to transmit the packet, I have to move through port 1. This is the process of learning, and this process of learning continues as the bridge forwards frames. So moving on to the third criteria that should be present in any of the transparent bridges, it should not involve in any looping issues. So the looping problem in transparent bridges must be overcome. But what happens in case of transparent bridges when we have such kind of stations? We have been analyzed, or that has been analyzed with respect to these four figures A, B, C and D. So in the first figure, if you look at during the learning process, the station A sends a frame to station D. The table of both the bridges are empty, as you can see. So from the bridge 1 also the table is empty, in the bridge 2 also table is empty. Both forward the frame and update their table based on the source address A, right? So now in the next step, now there are two copies of the frame on LAN 2. So now you can see on the LAN 2 that there are two copies of the frame, that is address A is leaving through port 1, address A is leaving through port 1. So there are two copies which is maintained by or which is present at LAN 2 as of now. The copy sent out by bridge 1 is received by bridge 2, which does not have any information about the destination address D, and it floods the bridge. Floods the bridge in the sense it will again pass on that information to bridge 1. So this keeps on working in the same manner, which creates a loop. And note that each frame is handled separately because bridges, they will be working as two nodes on the network but sharing the medium. Use an access method such as CSMA CD. So carrier sends multiple access with collision detection. The tables of both bridges are then updated, but still there is no information from the destination for the destination D. Then after avoiding such kind of looping thing, what we do or what is done at the third step is, now there are two copies of the frame on LAN 1. Step 2, that is whatever the packet that is received as the two copies on the frame of LAN 2 is now again transmitted back using the bridge 1 and bridge 2 that will reach the LAN 1. So now again the network is flooded. This process continues on and on. Note that the bridges are also repeaters and regenerator frames. So in each step that they try to find the destination D, there are newly generated fresh copies of the frames. So what we have is, to solve this looping problems, the IEEE specification requires, or it tells that we should make use, requires the bridges use the spanning tree algorithm to create a loopless topology. So you can go through the spanning tree algorithm as it is already learned. So you can apply the same for the topology that is existing here, and you can understand how a system connected with LANs and its graph can overcome this spanning tree problem. Problem of looping. Now we have the next topic, which is routers. So we know this router is a device which is connected between the physical layer, data link layer, and then the network layer. A router is a 3-layer device that routes the packets based on their logical address, that is depending on host to host addressing. So this router, as we can see in the diagram here, so this router is helping us to connect the LAN to the WAN. So it helps us to provide the connection between LANs and WANs in the internet, and it maintains a routing table of its own, which is that is required for making decisions about how to route the packets. Then these routing tables are dynamic in nature and are updated using the various routing protocols, which will be studying in the further sessions. Then moving on to, we have the other thing, which is a gateway. Gateway, as it is represented, that if it is capable of working at all the 5 layers, we call that as that connecting device as a gateway. Gateway is normally a computer that operates in all 5 layers of the internet or the 7 layers of the OSI model. This gateway takes an application message, reads it, and interprets accordingly. This means that it can be used as a connecting devices between two inter-networks that use different models. So for example, if we take a network that is designed to use the OSI model, can be connected to another networking model which makes use of internet model. So I can have the communication being set up between a OSI model and the internet model. So there comes the job of this particular gateway. So the gateway connecting the two systems can take a frame as it arrives from the first system, move it up to the OSI application layer, and remove the original message. So gateways, it also provides the security to the whole of the system that is present. Thank you.